is the graph of y equals g of x. Sketch the graph of its inverse on the same grid. So, some notes that we wrote before that we can look at. If the graph of the inverse is switching the x and the y, with the graph, we can switch all the x and y coordinates. So that means on my original graph I have negative, well let's start here, negative 4, 4. My x coordinate is negative 4. My y coordinate is positive 4. If I switch those, I would get the point 4, negative 4. If I took the second point here, which is negative 1, negative 1, and I switched negative 1 and negative 1, I would still get negative 1 and negative 1.
You don't alter the signs?
You don't alter the signs, you just switch the x and the y values. So on the next point I have 1, 3. If I switch the x and the y values, I would get 3, 1. And finally on my red graph, I have 3, 2. So I would get 2, 3. Now we have 4 new points, and we have to connect those dots. One way that you could do it is you could go in order. I'd say this one's connected to this one, so that means this one has to be connected to that one. This one's connected to this one, so this one would be connected to this one, and so on. The other thing that can help you is if you draw a dotted line and label that dotted line. That's the equation of y equals x. Does it look like the red graph has been flipped over that line to become the blue graph? Now mentally, it's harder to reflect over a diagonal line than it is a horizontal or a vertical line. For your brain, if you make a diagonal line and trying to reflect something over that, your brain finds that harder than a straight line up and down or a straight line, okay? Now, this is how you can cheat a little bit on your tests and exam, and they'll never notice. If you take your picture and turn it on your desk, it will become a horizontal line. And then you can check if it flips over nicely easier. And if anybody comes by, quickly straighten your paper again, and they'll never know.
Is that not allowed?
Yeah, we know how to just move the...
You are allowed to move it. It's not really cheating. That's right, it gets stapled to your desk. You're not allowed to turn your head. You can't move at all during the exam. But if you do try that, turn your page, can you see that it's a perfect reflection over that line? And that's probably easier for your brain to see than the diagonal one. Other things to notice. We noticed that this point, negative 1 didn't change. Why? Because it's on the line y equals x, and because the coordinates are the same. So we have another one here. I don't know what that value is, but because it's on the line, it also doesn't change. So it is something that is sometimes looked for in these questions. Do your points that intersect the line y equals x, do they stay at the same place? So that's part A. Is the inverse a function? Do you remember how to tell if something is a function or not? Something about x and y values. Did you ever learn
Something about not having these things.
the vertical line test?
That's what it's called. But it's pencil.
The vertical line test says if you take a vertical line and you move from left and right,
Isn't it like if it touches it,
if it touches it more than once,
it's not?
it's not a function.
So it's not.
So the blue one is not a function. The red one, look at the red graph. It's always only hitting one part of the red graph. The red graph is a function. So for B, because it says explain, now I'm going to write the inverse is not a function. Because it doesn't pass the vertical line test. This means some x values have more than one y value. If an x value has more than one y value, it's not a function. Okay? In fact, we use this in the English language. We say that something functions when it does the same thing every time, for the most part. Right? If your calculator, you went to it and went 2 plus 2, 4. Next time you went 2 plus 2, it's like 7. Next time, you'd be like, this is not working. You would say it's not functioning because it's giving me different answers for the same thing. So everything that is in your calculator, when you push enter, it gives you one answer. Because your calculator is built on the idea of a function. State the domain and range of the function and its inverse, so we have to do that for the red graph, domain and range for the original one, and for the blue one, for the red one. Do you want to use set notation or interval notation? Interval for this one. So the smallest x value is -4, the biggest x value is 3. Square brackets from -4 to 3. Interval notation for the blue one, the smallest y value is -1. The biggest y value is, for the red graph, +4. And an interesting pattern happens with the blue graph. If we look at the blue graph, now what's the smallest x value? -1, and the biggest x value? +4. And what's the smallest y value is now -4, and the biggest y value is 3. The big thing about inverses is x and y get switched. And they switch in everything. They switch in the equation if you're trying to find the equation. They switch in the coordinates if you're trying to do the graph. They switch the domain and range, because your domain is all your x values. All your x values now become all your y values.
That makes sense.
Right? All your y values become all your x values. So the idea of an inverse means x and y are getting switched. We also want to think that what that does graphically is it flips it over the line y equals x. Okay, questions for this one are 4 and 9.